Hey guys, welcome to Graphing for Polar Equations. I just wanted to introduce you to a little bit of graphing before you use your calculator, what these equations means and what these numbers are on the equation. I'm doing the generic forms, and once you start your lesson 4, you'll see what these numbers meant, okay? So let's start with the equation of a circle. I wrote the equations. There are two equations, r equals a sine theta, r equals a cosine theta. A is the diameter. So if I said, let's go back to the first one. If I said it's a sine theta, so anytime you have a sine equation, it's going to go on your y-axis. And A is your diameter, so this would be A units away, okay? And if it's a cosine equation, it will go on your x-axis, also called the polar axis, and your diameter is A, right? If it was negative sign, then I'm just going to sketch that also for you. So it would have, oh, sorry, this is wrong. This is cosine. Sine, I said, right? It'll be down here with the same radius of diameter of A. And I'm just going to change color. If it was negative, A cosine whatever theta, so it would have been on the left. So I guess you get an idea, and moreover you will be graphing for most part, but I just still wanted to introduce you to the whole idea of this. It'll be a negative A here and actually a negative A here, whatever that is. So that is one type of polar graphs, this equation of a circle. The second type I want to talk about are the limesons. They are of this form, a plus and minus b sine theta, or r equals a plus and minus b cosine theta. Yes, the sine and cosine determines the axis you're going to be. And remember, your a and b are always going to be positive. They are greater than 0. The plus and minus just tells you where will you be. If it's plus sine theta, you'll be above the x-axis, and if it's minus, you'll be below. And similarly for cosine, you'll be right. If it's positive, you'll be left if it is negative, right? And you can always check with the calculator. So how there are 3 different kinds that I'm going to be talking about. I also attached a sheet that you can download and look at. It kind of briefly does the whole picture of the shape and everything. So you determine by the ratio. If your ratio of A over B is less than 1, then it's called the inner loop limeson, and it looks like this. I just want to sketch them with you. So let's say I'm going to say it's a sine one. That's what it looks like. And if A and B are both equal to 1, if you divide them and the ratio is equal to 1, it's a cardioid, and that looks like this. It's like a heart-shaped thing. I kind of remember it from cardio. Cardio is like has to just do with something with heart, so that's how I remembered it. This one is called, if A over B, the ratio of A over B is between 1 and 2, it's either called one loop limacon, or in some places they also call it a dimple, and it looks like this, a little dimple here. Something like that. Okay, so again, I can talk to you about it. Cosine and sine determines the x-axis or the y-axis. If it's a cosine, you're going to be on the x-axis. If it's a sine equation, you'll be on the y-axis. Ratio determines the shape. So if you want to know how to graph them and you don't want to use the calculator, you need these 3 things. A plus B, A, and absolute value of A minus B. A plus B tells you how far it stretches on the main axis. So let's say, I'm just going to give you an example. Let's say I had 1 plus 2 cosine theta, right? And its r is equal to. So what's A plus B? It's 3, and it's a cosine function, so and it's positive, so I'm going to be on this axis. So 3. 1, 2, 3. So I'm going to be, that'll be my 1 point. So A, how far it stretches on the opposite axis. My A is what? 1 here, so it's going to be, that would be my other 2 points that I need. And a minus b is your lower point. So if I do the absolute value of a minus b, which is just 1, it's your lower point. Now, before I even determine the lower point, I should have first recognized which shape is it. What is it? If I do the ratio of 1 over 2, which is less than 1, so it is the inner loop limacon. So it's going to be looking something like this. So it's going to be on the inside. So that's my, because it says inner loop, so that is where that a minus b point will go. So I'm just going to sketch it. They're a little hard to, but once you get a hang of it, they're not that bad. So that's what it'll look like, right? We'll do more in the lesson, but since I had all this literature written here, I wanted to explain what this meant and what we were working with. The other kind of polar graphs, or the last ones we'll be working with, are rose curves, and they are of this form: r equals a sine n theta or a cosine n theta. Now, a is the length of each petal. They look like this, something like this, literally like a rose curve. I'm just gonna, something like this, a flower. And a is the length of each petal. If n is even, then the number of petals is 2n. So let's say if I had 2 here, a sine 2 theta, I would have 4 petals in all. And if n is odd, then n is the number of petals. So if I had 3, let's say I had a cosine 3 theta, so in that graph I'll just have 3 petals. I hope it cleared up something before. I didn't want to start graphing before you kind of understood where these numbers came from. You don't have to memorize them. You will be using the calculator, but I felt it'll be a good introduction video to polar graphs. So you can watch the lesson after this.